Okay, now here's a more challenging one. I'm going to take A this way. Oh, sorry. I wanted to draw A down here. A going that way, A going this way. I'm going to identify these edges together.
And then same.
And then I'm going to identify B going this way with B going this way. Okay? So let me get rid of our torus and just put this. So see if you can imagine what's going to happen when we fold this up.
Well, if we want, we can't really fold it. We could fold these corners together to make A correspond with A.
Ah, very, very, hey, high five. This corner matches up with this corner because it's the far corner on the B arrow. Far corner on the B arrow. It's also the far corner on the A arrow and the far corner on the A arrow. So this sort of folds up like that, and then these sides sort of zip up, and these sides sort of zip up. So what sort of shape do I have when that happens?
You have a triangle when you fold over.
Because
Yeah, it's a right triangle.
Okay, I do get a if this was just smashed down completely and folded across, I would get it. I would, if this was and this was a square, I would get a right triangle. But these points in the middle aren't being smashed on top of each other. I'm leaving some air in the middle.
yeah, you sort of get another torus.
But
Okay, does it have a hole in it?
Because
Yeah.
this has a hole there.
Well, are you sure it has a hole?
well, if you smash it down, it won't have a hole.
What point? This point is identified with this point, but what about a point here? Where is this point going to be identified with?
It's some point on this edge.
Okay, coming down a little bit, about the same. This point here is going to be identified with this point over here. So there, we're actually going to be gluing down this edge on top of that edge, right? Pretending this was a square. And then this edge is going to get glued on top of that edge, right?
Yeah.
So does it have a hole in it?
No,
I know.
it doesn't have a hole.
It doesn't have a hole in it.
But it's the two triangles layered on top of each other.
Sort of folded around, almost kind of looks like
An egg.
this egg, doesn't it?
Hmm.
Can you see that?
Yeah.
If you imagine if I just made a cut in this would kind of unfurl out and it would be flat.
Yeah.
Now, does it make sense? This says I can sort of go around and always pop out somewhere else and keep going around in a circle this way. These sides identified together means I can keep going on these sides a different direction. But on an egg or on a sphere, I can go around this way and I can go around this way, two different directions, right?
Yeah.
So can you see how this folds up and becomes sort of an egg shape or a sphere shape? There's no hole like we had in the torus.
Yeah.
Can you see that, or are you struggling to see that?
You can sort of see it.
What about you?
Not real. I can just see the two triangles that fold.
You can see this folding up like this, and then I identify those edges together, and I have, can you see how I'm getting something left in the middle here?
Yeah.
And on that side I'm getting something left in the middle, and then I could maybe silly putty it into this shape.
Yeah.
You see that?
Yeah.
Okay. Now let's go on to the Klein bottle.